Hello everyone, welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
What I'm doing.
So today it's going to be the topic of the video again going to be about cybersecurity, and hopefully it will be some sort of educational content if I can get things to work. But yeah, we're gonna take a look at something. So let me show you what I saw. So today I just saw this article that FBI is offering $10 million rewards for the capture of a hacker, and I was reading this. This is apparently the guy's name, and this says 22-year-old hacker from Grozny in Chechen Republic, doesn't matter. So yeah, I was reading this article and I saw this, apparently this neckbeard is him. So yeah, he's wanted by the FBI and all that stuff. I wanted to know what he did, like what is the technical aspect of what he's done. So I was reading it and I saw that the conspirator infected computers on these networks using malware known in cybersecurity community as Whispergate. That's all I needed. So I saw the Whispergate and I started searching, Googling like a Whispergate malware sample and stuff. It wasn't straightforward. I saw this web page from Cybel, whatever. It doesn't matter. It's not really detailed analysis. It just tells you what this is doing. It's a general overview of the app and of the malware. And all the way down, that's not what I wanted. I wanted this. So I found the hashes for all stages of this malware. Okay, so today I just want to show you, like, when you see something on the news, $10 million reward, and then some 22-year hacker like destroyed everything. Okay, I always take these things with a grain of salt. I just want to take a look at what they have actually done technically in terms of their technical skill. They have done what they have done and FBI is indicting them. I just want to understand the technical skills that they had and what they have done. So here are the samples that I got from this article. And I found the hashes and I have some accesses. I was able to turn those hashes into malware samples. So these are the malware samples, and let me fire up my tools. So let's start with Ghidra and let's see what these malware actually look like. Okay, let's go with the stage 1. So these are from the old video, so let's remove that. And let's go with the stage 1 actually. Let's take a look at it and see what it is actually doing. So it looks like it is compiled using GCC. Odd choice, I'm gonna say, for Windows application development, but it is what it is. Let's load this in Ghidra, latest version, and take a look at it. Okay, so these are the standard stuff that you would see in a GCC compiled, GW compiled stuff. So let's go actually to the application. These are again SEH, exception handler and stuff like that, and all the way down this is where the main thing should be happening. Let's go in there. So first thing that caught my eye is actually this. That is the physical drive access to the root partition of the computer. So if your operating system is installed on C and your Windows is booted from there, it's basically getting a low-level access to your C drive where the Windows is installed. And it is calling create file with a bunch of, obviously, as you know, I turned off my antivirus. So it sets up a bunch of parameters. Like for instance, this one, I don't know what that equates to, but I can figure it out quickly. So if we search create file Win32, not example, I just need the, yeah, this. So this is the 1000 is being set in FFF0 and it's being used in the second argument. So second argument is the desired access, and if we go to desired access, they're generic. Okay, so yeah, it's doing this and it's generic all. So it is getting read, write, execute access to physical drive 0 and low level access to the disk itself, and the other arguments doesn't matter. And then I see a write file, so it is just getting access and calling write file on that with the size of hex 200, which is decimal is 512, and that's exactly as you suspect is MBR. MBR is the master root record of your computer, and when you install an operating system, either Linux or Windows or any operating system, basically after the BIOS, UEFI, whatever, it just comes to MBR and gets executed, and then that your operating system gets loaded. And I just have to now locate what it is writing. So write file API If we look at the write file API, you can see that the second argument is the buffer. So the second argument is again this ff0. Oh, okay, it's passing this variable. And so let's take a look at that. Looks like this. Okay, this looks like a binary blob of data. Yeah, here your hard drive has been corrupted. Okay, so this is the message probably they are leaving. You should pay us 10K via Bitcoin, and that's the Bitcoin wallet address, and there's the ntox ID stuff. So yeah, there's a message, a text. Oh, here 55AA. That 55AA, when you see it in like this topic physical drive 55AA, that's indicator of the master boot record. So I want to extract this. So what I'm gonna do is go back to the sample. Now let's open this in hex editor and look for that hex byte. So it was 000055AA. Okay, so yeah, this is your hard drive has been corrupted and whatever, and it's getting repeated a couple times. I just need one of them. So if I start from 00, where was that? 55AA. Yeah, here. So I want to start from here, go all the way to end of it, which it gets repeated again right here. And if you look at the length, look at that. Length is 200 hex. So it's exactly the amount that it was writing to the disk mbr. So let's create a new file and save this mbr.binary. Okay, so we extracted the binary mbr code that it is writing in the stage 1 of the application. So now we're kind of done with this. I'm gonna close this one. Let's take a look at the master boot record, and we have to set this to the real mode. So as you know, mbr is there, and I want to be able to also change the base address. Has to be 7C. So as you know, also mbr base address starts from 7C, so everything else looks okay. I'm gonna save that. Oh, go back, and let's load that in the Ghidra now. It's probably not going to. Okay, how about if I press D? There you go. Okay, so we got something going on. Yeah, pseudocode looks nice. It looks like it's iterating and doing character by character, and calling this function. I'm assuming this is going to be the text. Yep, so your hard drive has been corrupted. So it is basically character by character reading from this string, whole length, and then calling this function. If we go to that function, if you look at the assembly side, it looks like interrupt 10. And I'm sure interrupt 10 is related to Intel 86 interrupt list. Let's see if we go to 10h. Yeah, so video services, and this should be related to print, write pixel, write string. So it depends on the H as well, 0xe. So that's going to be write character in TTY mode. Okay, so it is reading from that string and printing it using that interrupt 10, and it is printing character by character on the screen, which is the ransomware note. Okay, and that's pretty much it. And about the MBR thing, so the master boot record. Let's not get stuck here. So let's take a look at it. Stage 2. In the stage 2, let's see what happens in here. So, oh, this one is MS Core. This is, I shouldn't have done this. So this is a .NET DLL. I'm not gonna open it in Ghidra. So when it is .NET, you need a tool for .NET. So I am going to open it up in dnSpy. Okay, all right, so we have that. Let's drag and drop that in here. Okay, already. Okay, so we are seeing some Russian characters in here pretending to be Microsoft. Yeah, it says Microsoft Windows. I'm sure these are also in Russian, something for Microsoft. They're mimicking something. So let me actually rename this to test.exe. I just want to see. Oh yeah, they have a digital signature, and obviously it's invalid. So yeah, it's some made-up signature. They're pretending to be Microsoft Windows production PCA certification pass. Yeah, it's some invalid signature inserted there, just trying to bypass antiviruses. Well, I'm gonna be honest, I don't think antiviruses are that stupid that just because, oh, there's also a logo, and that logo looks like I don't know what that is. So yeah, it looks like something, a box and a P on it. So yeah, the antiviruses, usually the good ones, you will not fall for this, an invalid signature. Oh, that looks like a proxy app thingy. I forgot the name, but yeah, it looks like something that I've seen before. Okay, and by the way, they compiled this project under the name TBOPBA. H, whatever that means, which means nothing. So let's take a look at this. Oh, it's obfuscated. It is obfuscated. Yeah, it is obfuscated. But we don't really care because it's not really that mangled. It is manageable. Let's take a look at it and see what it is doing in the module here. Oh, there you go. There you go. So it is downloading this URL, which I'm sure Discord have taken down. I hope, at least. Let's see. Yeah, the content is no longer available. So apparently they uploaded the next stage to Discord, and this is how they are downloading it. And looks like after that they downloaded, and I'm sure they are loading and starting it and executing it. Let's take a look at it. Oh, I see some base64 string in here. String text, where it is used. Oh, PowerShell. Okay. So PowerShell, encrypt, and this, and then the text too. Oh, so it's okay. So let's take a look at it in CyberChef. So CyberChef, let's go over here and paste this, and then they append this to it, I guess. Okay. And then let's say from base64. Oh, this is Unicode. I can still read it. Start-sleep, but let me clean that up. So let's replace x/0 to nothing. Okay, yeah. Start sleep -s-s10. So that's nothing. What is this doing? So it's basically starting a PowerShell process just to sleep for 10 seconds. That's it? It looks like it. Okay, so let's keep going. It's the module called facade, so whatever that means. So let's take a look at it if there is anything else in here, anything special. It's not that obfuscated. This is okay. This is passable. I have to check later to see what, I don't know. It looks familiar, but I can't tell you exactly which obfuscator being used. Oh, here you go. It is invoking a method. It's loading a function. So let's take a note of that and save this. So this is going to be function called. So it is loading the next one, which is a JPEG that is downloaded, and then it loads that and executes. So calls this function in that DLL and the next stage. So the next stage, I saw that it was a DLL in this article. It was saying stage 3 DLL, and this is something that is used in other botnets as well. Apparently it's not specific to this actor. So I'm gonna say that this fella, the neckbeard, didn't actually do the stage 3 DLL. It's a loader that's used in some other campaigns as well. So that being said, let's take a look at the stage 3, and I am going to assume this is .NET because it was loading it and starting it. So let me try. I had the dnSpy open. I closed it. Okay, let me open it again. Let me drag and drop. If it doesn't work, it doesn't work. Okay, it didn't work. Oh, actually, it didn't even load at all. It looks like a problem. Okay, let's take a look at it in hex editor. Product version. That's in the reverse order. Let's go to the end. Yeah. Oh, you see that? MZ, and then this program cannot be run in DOS mode. Okay, so yeah, it's a reverse file. Let me put together a Python script real quick, and then we are going to decrypt this. Hopefully, give me a couple seconds. Okay, so now let me show you what I got. I stole it off of internet. I didn't really do this. I just modified it tiny bit, and it is using mmap trick to reverse the binary. Okay, so let's actually do that and say Python reverse.py b2. Okay, so it's gonna give us out.bin, and if we open this one in hex editor, ta-da! Okay, now we got a proper PE to load. Let me remove this and let's rename this stuff properly. Stage 3. So we are at stage 3. If we load that in here, yep, as suspected, that's a .NET application. And let's take a look at it. Yeah, that is very, very obfuscated. Yeah, you see that? That's a lot of... Oh, this is familiar. Yeah, the name. Hold on. Okay, so this is easefuscator. I remember. Easefuscator, this one. I don't know how it is pronounced. Easefuscator, I guess that's the one. They are using this one to obfuscate, and it does have virtualization as well. So this is what's happening in here. So static analysis is gonna suck on this one, but this is a long story. This basically, in the other malware that was using this DLL as well, it basically uses, you know, some useful tool. I forgot the name. Hold on, let me find it. Yeah, so this one, advanced run. So it is basically using advanced run to to run the application with admin privileges, and also to start kills the antivirus, kills the Microsoft Defender unnecessarily, and then it moves to the actual final stage, which is the most important part of this. So I'm not going to get into this because this is not something that this actor that is does have a $10 million reward on his head, he's not the one who worked on this. So just used something pre-made. So let's go to the stage 4, and that's the last stage. So if I drag and drop this should be the most interesting part, because all that you saw was just layers and stages to do things, except the MBR part. So MBR part is independent. So MBR part overwrites the master boot record. So if you restart your computer, you don't have an operating system anymore, and that's all it does. Other than that, the next 2 things that we reviewed was developed by that dude and wasn't doing anything other than just trying to hide what it's trying to do. That was it, and then killing the Microsoft Defender. Now, again, same thing. These are the GCC. Very odd choice, I'm gonna say, but it is what it is. And yes, again, we skip all that. We come right here. So this is going to be the main, and if we look at it, it is getting the command line argument and the startup info. This is pretty standard and nothing in here special, and then calls this function get module handle. That's also normal. Okay, so we have 1, 2, 3 exit windows. So it calls exit windows X with a parameter 14. I have to see what that looks like. So argument 14, which one is that? Where is the 14? Oh, that was 14 in hex, right? Yeah, so it's going to be 20, or we have to see 14. So it's going to be forced and this. Okay, so it is going to be combination of 2 arguments. I think it's going to be these 2, forcing, and then if hung forces it, doesn't matter. Anyway, so this actually shows you when these 2 functions are done, it is going to exit Windows, basically reboot, shut down. Okay, and it's going to do that. So let's take a look at the first one. Okay, it's very familiar. I've seen this in many other ransomwares too. So if they start with the letter A, you know what it is. So they go character by character. In Windows, as you know, the drives are alphabetic letters, right? A, B, C, D, E, F, G, it goes all the way up, right? So it starts with A, goes all the way to Z, probably. So get logical drives, gets the list of drives, and then iterates through those letters, and then it checks the drive type, looks for it. If it is not type 3 or 4, it skips them. Okay, so let's take a look at this API. I don't know the type 3 or 4 what those are. So yeah, here. Okay, so it looks for type 3, which is fixed drive, and type 4, which is a remote drive, which is like map drive, shared drive, right? So it looks for fixed or shared drive. If it is removable drive, so they are nice enough to not encrypt your USB devices if it is inserted into your computer, or if it is CD-ROM or RAM disk, which really doesn't make sense. So yeah, usually what I've seen in malware is they just do these 3, even removable stuff, but this one apparently skips the removable. Okay, and then once the drive type is a fixed drive or a remote drive, it calls this function on that letter. So let's take a look at it. I'm sure, yeah, so okay, if you go with the dot or the dot, you go one level up. So it's skipping those, and it is skipping the recycle bin. It's not touching the files you've deleted, and then it starts doing stuff. Home drive gets the home drive, and then star dot this. Okay, oh yeah, so it's recursive, it's calling itself. Okay, so it's a recursive function. It keeps calling itself, and if everything is fine, it calls this function. Let's take a look at that one. Nothing special in here. Let's take a look at this function. Okay, if compares to HTML, what is that? Ooh, look at that. So here is the list of extensions, probably, yeah. So it's comparing the file extension to be HTML, HTML, SHTML, ASP, PHP, and who writes PHP these days? Anyway, docx, XLS, PowerPoint, and OpenOffice formats. Ooh, that's a long list. Wow. Okay, even jar I saw somewhere, I think. Yeah. What? They go after your compiled jar files too, you know? They don't let that one go. .dip, I don't think I know what that one is. Past? Is that really? For Delphi, Borland, Pascal? What is that? I don't know. Anyway, it's a long list of extensions. So why just not go star.star? I mean, it's a lot of extension. Anyway, so it checks to be one of those extensions, and then and only then it encrypts. And then probably this one. Okay, it's the iterator, so it's calling itself. And yeah, find next file API. You will see that in a lot of ransomware, to be specific. Okay, and then what else was there? Let's go all the way back. There was the 3 functions. So that was the letters, iterating and encrypting. And this is, oh, look at that. Yeah, every time you see the ping this and with this executing this command with CMD, it's a delay. You will see that in a lot of malware. They basically run an application, CMD with command prompt, and then passing these arguments saying ping 11111, which is going to just time out. But in order for it to time out, and it's sending 5 times, so it's going to take a while to time out. Okay, and then as you can see, it is waiting. Basically, let's just assume that the whole thing from here to here is just a sleep. Okay, call that sleep 5 seconds, something like that, 10 seconds, doesn't matter. And then it is deleting forcefully and quietly, which means doesn't ask for confirmation, a file. And that file is right there. I was going to say, it says right there, get module file name itself. So it's getting its own module and its own file name, and that's what it is. It's basically self-deletion function. It starts ping, which is going to delay for like 4 or 5 seconds, and then it will delete itself, and then it finally exits the windows. So that's pretty much it. That's how you would analyze a malware and take a look at these things. So every time I see something on the news, when I have some free time, I just want to know what it is all about, you know. So some people talk about it. I just want to know what it is and yeah, what they have done. So what I'm gonna say is, he's not really some sort of a master hacker or does very advanced programming skills or capabilities. I'm not gonna help anybody do a better job in terms of ransomware, obviously, but that is nothing special. And with that find first file and a single thread, good luck. That's gonna take forever. And anyway, let's not help bad guys. But anyway, I just wanted to take a look at this dude's malware, and I'm gonna say it's nothing special at all. It just shows what you would expect from a 22-year-old developer, and compiling with MinGW in GCC and Windows, and when you're developing, I'm not gonna go there. So anyway, I just want to take a look at it. And yeah, if you guys like this type of content, let me know. I would take a look at more malware samples as I go. I did another Android video that I'm still editing, so when that one comes out, I will also publish this one. So I want to include cybersecurity stuff, as that's my job and that's what I'm most passionate about, as well as the SBC stuff that I usually do in this channel. So let me know what you think in the comments below, and hope you enjoyed this video, and hopefully I will do some more if you guys are interested. Thanks for watching, and I will see you in the next video. Bye for now.